Hi everybody, my name's Eli. I'm an automation specialist here at Captron North America, and today I am going to be walking through IO-Link output data on our series4x with this MER 54631 block. So I get a lot of questions on IO-Link process data, particularly with our buttons. If this is your first time setting up a PLC, this is a really good video on how to address the buttons and talk to them. What's up? Today we are going to be going over IO-Link process data using our digital display buttons. And to complement that, I am using the MER 54631 block to show you what is process data. So when you're using a button, you generally think of a button being pretty dumb. It's either being pressed or it's not pressed. But with IO-Link, we have this wonderful thing called IO-Link process data. This allows our sensors to be quote unquote smart, and we can control them from the PLC using this process data. So on the MER block, I can look at our process data from this tab, and we can see our input and output array. So process data is an array of bytes with a different length depending on the sensor, and can be wrote to from the PLC, or with the MER block, you can use MQTT and a REST API. So to get started, one thing that we do need to do to be able to control by IO-Link process data is go to the LEDs tab and change LED control mode to either scene controlled by IO-Link process data or advanced. Today we are going to be using advanced to show the different kind of functionality you can get out of the button. So starting with input, no matter which kind of control you are using, input will remain the same. We do not change input. So we have pin 2, pin 4, and pin 5 as our first bytes. We also have our actuation flag. You will probably find this useful if you're running IO-Link on a PLC. This is where you would read your input from the button when it is pressed through IO-Link. If you're not using IO-Link, then it's a simple input wire that you would feed to your I/O. You also have actuation count. So every time you press the button, you will see this number go up. Actuation strength is the capacitive field around the button. So if I put my whole hand over it, we should see this number jump up. Well, maybe I'm not that strong. And the surrounding brightness. To help our buttons actuate easier, we do read the brightness around the button to make sure that the button actuates. So if you do have gloves on, you can still use our buttons. And the more confusing part of process data is the output. This is where we're going to write data to it. We have active LEDs, our LED brightness, our RGB values, our LED effect, frequency, and display digits. So it's very useful to reference our TRM. So down here we have scene controlled by a IO-Link process data. Oh, this is the wrong one. Advanced control. This basically walks you through the byte allocation and where you need to write through to. You have active LEDs, of course, all the way down. So for active LEDs in particular, there are 16 LEDs on the button. If you want the LED on, you write 1 to it. If you want all of them on, you would write 1 16 times, or in hex, FF. LED brightness, you have an option to write from 0 to 100, and 255 if you just want automatic control. And it will change based on the light level where the button is. Super dark, I believe it darkens or brightens. And our RGB values is pretty self-explanatory. You can make any color you could possibly imagine with these RGB values. Our LED effect, we have a lot of options on what you want the button to display. So if you want, for example, an animated arrow down, you would write 13 to it. And that goes all the way to 21. And the effect frequency is the hertz of the LED effect. So you can imagine really slow, 1, really fast, 6. And our display digits. These are for the 4 digits that can be displayed on the button. You need to write the ASCII values. So if I wanted to write, I believe A is 65. I don't know why I know that off the top of my head. You can write 65 to this byte and it will display an A. It's very useful to have a PLC that can, pull the ASCII values for you. And the display brightness, this is the brightness of the display digits from 0 to 100 and unused. So we can go through, an example of writing to it. And the MERT block has a nice feature where you can just write directly to the button from the web server. So starting at byte 13, and what would be helpful right here, mixed up, is to be able to reference the TRM. So we'll start at byte 13, which is our active LEDs. I want all of them on. So is this in hex? Yep. So I'm just going to write 255. Byte 11 is going to be our LED brightness. Just going to go ahead and make that 100. And our RGB values, I'm just going to put random, did not write there, 40, we'll do 75, and 20, why not? Byte 7 is going to be our LED effect. So I'm going to do 22. And our frequency, we'll just keep that as default. 4 through 1 to keep this tutorial easy. we are just going to do 65. Oh, now what did I do wrong here? Did I 0? Oh, need to shift everything. Okay, back in action. So I see the mistake I made. I just need to get rid of this. Byte 1 should be the brightness of the digits. And yep, it worked. And that is how you would write to the process data using the MIR UI. Of course, on a PLC, it's going to look a little different. You're going to want to set up tags for each byte where you can then just write your values to. And the nice thing about this is it makes these buttons dynamic and can change at any point. So if one day I like blue instead of green, I might just change that to blue. That's it. So I hope you guys learned something today, and if you do have any more questions, please feel free to reach out to me at my tech support email. That will be in the description of the video. And if you get the chance, subscribe.